Hello students, this is Miss Dalton, and we are going to show how to write an equation in Vertex and standard form given points on the graph. So let's review. When we were writing the linear equation, we could write that if we were given a couple of pieces of information. If we were given the slope and the y-intercept, we could use slope-intercept form to write our equation. And then the other way is if we were given a slope and a point, we could write the equation. I'm not going to go over that right now. You should be able to remember that from when we did linear equations. But again, those were the two different ways that we could write our linear equation. Well, so now that we're dealing with quadratics, you have two forms, right? So we've already talked about that. Our two forms are vertex form, which is here, and standard form, which is here. So if we're given some pieces of information, I'm going to show you how you can write your equations in the two different forms. So let's look at number 1. In problem number 1, it says, given the following points, write the equation of the quadratic equation in vertex form and standard form. Okay, so number 1, we're given the vertex and we're given a point. Now I want you to remember that the vertex is just your h and your k. And a point, well, a point will be able, any point on the quadratic will be able to work in the equation for x and y. So let's use these two pieces of information to write our equation. So we're going to first start in vertex form. So I'm going to use the vertex form, so let me write that down. Y equals a x minus h quantity squared. X didn't come out really good there. And then we've got our plus k. So let's take everything that we have and let's go ahead and plug it into this equation. So my y value is 3, so I'm going to put a 3 here, equals a, I don't know yet, so let's put an a, parentheses, your x value is 0, and then minus your h value. My h is 1, so it's going to be a minus 1, and then squared, and then plus your k, which is 2. What you're going to do is you've got everything that you need except for a, so let's go ahead and multiply this out and let's figure out what a is. So keep your 3 here. 3 equals a. 0 minus 1 is negative 1, and then negative 1 squared is 1. So I'm going to put times 1, and then plus 2. So we're just solving for a at this point. We're going to subtract 2 from both sides, and that gives you 1. 1 equals a. So I know that my a value is 1, so let's go ahead and write our vertex form with using your a and your vertex. So I'm going to take this vertex and I'm going to take my a, because those are the three pieces of information that you need to write the vertex form. Y equals a, which is 1. You can put a 1, but you don't have to. And then x minus h, so 1 minus 1 squared, and then plus 2, which is your k. Alright, so here it is in vertex form. And then now, once you have it in vertex form, you're just going to multiply that out to get it into standard form, which is what we've been doing these past few days. So let's go ahead and do that. Y equals 1 times x minus 1 times x minus 1 plus 2. So we have to multiply first. Y equals 1. Multiply these together. So you're going to have x squared minus 2x, I'm just doing this in my head right now, and negative 1 times negative 1 is positive 1, and plus 2. Now, because I'm multiplying by 1, that's going to stay the same, so really it's like the 1 is not even there, and I'm just going to combine my like terms, which is 1 and 2. So I'm going to have for my standard form, y equals x squared minus 2x, and then that would be a plus 3. Okay, so there's my standard form. Okay, moving on to number 2, I want you to try to number 2 on your own. This is the secret example for the first secret example. So I'm going to have you do it on your own. Just keep in mind that your vertex is your H and your K. And then the y-intercept, well, that's still a point, so this is going to be an x and a y. So go ahead and use that and write it in vertex form and standard form. Okay, number 3. On number 3, they give you 3 points on the graph. Points are 1, -2, 3, -4, and 2, -2. Now, because I don't know if any of these are my vertex or even what my vertex is, there's actually 2 different ways that we could solve this problem. One, we could use matrices to solve it, and so I'm going to show you how to do that. The other way that we could do it is to use quadratic regression. Now, we've already learned how to do linear regression, which is making a table and then using your calculator to do the linear regression to actually get your equation. Tomorrow in class, I will show you how to do the quadratic regression, but for these notes, I'm just going to show you how to use matrices. Okay, so let's go ahead and get started. What you're going to do is you're going to take the first point. Okay, so my first point is 1, -2. Now, what this has in common, all of these points are on the same quadratic, which means all of these points should work in the quadratic equation. So what I'm going to do is I'm going to take this point right here and I'm going to plug it in for x and y. And what's going to happen, and I'm going to put this into standard form. So what's going to happen is you're going to have an A, B, and a C that's missing. So my standard form, just to remember what it is, it's y equals ax squared plus bx plus c. So take these values and plug them in for x and y. So if I plug it in for y, I'm going to have -2 equals a times my x value of 1, and I'm going to square it, plus b times my x value of 1, and then plus c. So then this equation would be -2 simplified. -2 equals 1a plus b plus c. Okay, now keep that in mind. Go ahead and put a little box around it or something like that, because we're going to use this in just a second. Now let's take our second point, 3, -4. So basically the reason why we're going to use matrices on this is because a matrix can be used to find values that are the same in multiple equations. Well, because all of these points are on the same quadratic, my A, B, and my C values should be all the same in all of these equations. So I'm just plugging in the points so that then I can solve for my A, B, and my C. So let's plug this one into standard form now. So it's y, which is -4, equals A times your x value of 3 squared plus b times your x value of 3 and then plus c. So notice I'm just taking these values right here, put that in for x, put that one in for y. And now let's simplify it. So -4 equals 3 squared 9, so that would be a 9a plus 3b plus c. Okay, let's go ahead and put a box around this one because that's going to be my second equation that I'm going to use for the matrices. All right, my next point is 2, -2. So let's put 2 in for x and let's put -2 in for y. Okay, so y, -2, equals a times my x, 2 squared, plus b times 2 plus c. So -2 equals 4a plus 2b plus c. And there's my third equation. Okay, now if I'm going to use matrices to solve this, I want you to keep in mind what the equations looked like when we did use matrices. When we used matrices, the equations were in the form ax plus by plus c, well, equals the number. So I'm going to kind of just switch these around. My first equation is going to be a plus b plus c equals -2. And then my second equation just switch it around. 9a plus 3b plus c equals negative 4. In my third equation, 4a plus 2b plus c, and that equals negative 2. All right, now since I have 3 equations with 3 unknowns, then you should know how to set up your matrices, but let me go ahead and do that for you. Your first matrix is going to be all the coefficients on the left side. Okay, so my coefficients on the first equation is just 1, 1, 1. Second equation, 9, 3, 1. Third equation, 4, 2. I know that looks like a negative 2, but I was just trying to make that plus sign more visible. And then 1. Okay. Now, once you write down your first matrix, you're going to take the inverse of that, and it's going to get multiplied by your matrix over here. Those numbers written as a matrix. So it would be negative 2, negative 4, negative 2. Okay. Go ahead and do that on your calculator. Now, if you don't have your calculator with you, that's fine. If you'll just finish it when you come into class tomorrow with a calculator. Hang on just a second and let me do it on my calculator and I'll get you that answer. Okay, so after you get, you type this into your calculator, the matrix that you get from your calculator is negative 1, 3, negative 4. Okay, well, if you remember, what that means is that your A is equal to negative 1, your B is equal to 3, and your C is equal to negative 4, because that's what this answer gets you. Okay, it gets you the variables that you were trying to find. So your standard form is y equals negative 1x squared plus 3x minus 4. And if you were to type that in on your calculator to check it, you could go to the table, and your table should show all of these points for that quadratic equation. So there's your answer. Okay, I know that that's a lot of work, and again, tomorrow I will show you quadratic regression, and you can choose whichever way you want to solve it. This is a little bit easier if you don't have a calculator with you, because you could do this by hand. You don't have to have a calculator. Quadratic regression is a little bit easier if you do have a graphing calculator. So number 4 is going to be one that I want you to try on your own. I at least want you to set it up to where you have your 3 equations like you do here, where you have this equation, and this equation. You should be able to go ahead and set up your matrix equation here. And then if you don't have a graphing calculator, that's fine. Just have those 4 pieces of information set up so that all you have to do is just type it into your calculator when you come to class tomorrow, and then you'll be able to get your standard form. So I will see you in class. Have a good evening.